Students, how are you? I hope all you are quite fine and all is well in your life. Today we are going to discuss acidity and basicity of organic compounds. This is lecture number first of acidity. We have to study the total 8 to 9 lecture of acidity and basicity, since it is connected with the chemical bonding and equilibrium, so it is a little bit complicated. I hope your basics is clear. So if your basics is clear, you can understand perfectly here. So without delaying, let's start the acidity first lecture here. Okay, see here students, I write here acidity. Okay, still you know one thing, from the equilibrium we have done that any weak acid or a weak base, how to find the strength of the weak acid or weak base? We can find the strength of the weak acid and weak base in the solutions. Means either you take any polar protic solvent or any space in water you can take. So in the water we add the weak acid or weak base. So as you know, weak acid or weak base will not dissociate completely, so the equilibrium will set up between the ionized and ionized molecules, correct? So through that way we can find that how many H plus ions is undissociated in the solutions. So through the number of H plus ions we can find the equilibrium constant, or through equilibrium constant we can find the H plus. So if you have more H plus ion in the solution, it means that is the more acidic, correct? Or if you have more the Ka, that means the more acids you have. Similarly, we observe in the base also, same thing. So here, I write here, any molecules which is weak, just we assume the weak substances we have, which dissolve in the water. So weak substances Ha, which dissolve in the water, that's we form that equilibrium will set up, and H plus A minus. As we know that H plus and H3O plus at low concentration both are equal. So either you can write H plus or H3O plus. So equilibrium will set up, and then we will write the Ka is a H plus into A minus upon Ha. You can see here clearly that the equilibrium constant increases, then H plus increases, correct? So through this equation what we can observe here, that Ka increases, it means H plus increases. So acidic strength increases with the Ka or H plus ions. At the same time, we can say that the pKa is inversely proportional to Ka. So what we can say that the higher the pK, lower the Ka, correct? So you can say that either the H plus you can deduct which is more stronger acid, or through Ka or through pK, correct? And we know that if acid is a very strong acid, the pK is near about zero. So we can say that, so if acid is stronger, means good acid is a pK around 0, right? And weak acid is less than 4, correct now? And weaker acid, or you can say that weaker acid is greater than 4, correct now? So we have done that the good acid, the pK around 0, and the weak acid is less than 4, and weaker acid is greater than 4. Fine. Still now the most important thing, that the factors which influence the acidity. How many factors which influence the acidity? We discuss one by one. The most important 3 factors here. The one is strength of Ha bonds. Second, electronegativity of A, and third, the conjugate anions. How much conjugate anion is stable? That's also very, very important, because we understand through the example here. So the 3 factors I write here. The factors which influence here, factor which influence the acidity. The number one factor I write here. Number one is strength of HA bond. Correct? Strength of HA bond. Right? Here is bond. Second is electronegativity of A. Electronegativity of A. And third here, strength of conjugate anions. Strength of conjugate anions. Correct? One by one we understand all these three factors. How the strength of HA, how acidic strength depend on strength of HA, and how electronegativity, acidic strength depend on electronegativity, and third, how conjugate anions decide acidic strength. So one by one we understand all the three factors. Just to write down, note down these things. Okay? Now we understand here. C strength. The one factor is first we understand that strength of HA bonds. See still one thing, top to bottom when we move in the group 17 or 16, what we have done, we have HF, HCl, HBr and HF. Correct? So top to bottom size increases. Since top to bottom size increases, hence the amount of energy required to break the bond will be very less. Because HF is very small size, so more amount of energy will be required to break the bond. HI is bigger size, so less amount of energy will be required to break the bond. Correct or not? It means what I am telling you, it is less endothermic than the HF. So bond dissociation energy will be very less in HI. Correct or not? So bond dissociation energy of HI is very less, hence acidic strength will be very high, because as we know that the bond dissociation energy is inversely proportional to the acidic strength. So what we will write? Bond dissociation energy inversely proportional to acidic strength. Correct? So bond dissociation energy is inversely proportional to the acidic strength. Right? So therefore, what we can say, HI is a stronger acid than the HBr, and then the HCl, and then the HF. Fine? Okay. So now next point is electronegativity of A. When we move left to right in the periodic table, what we can observe here, CH4, NH3 and H2O and HF. Correct? One is CH4, second is ammonia, third is water, and fourth is HF. When we move left to right in the periodic table, the electronegativity increases. Since electronegativity increases, hence the acidic strength increases. Correct? So left to right, acidic strength is going to be increases. So HF is stronger acid than the water, and water is a stronger acid than the ammonia, and the ammonia is stronger acid than the CH4. Correct? Now third factor is strength of the conjugate anions. Students, see that I write three examples, and through three examples you understand here. The one is, here the compound I write, one, in the both the place there is a hydrogens. Second is here, again hydrogens, and there is a one double bond, and third is here one hydrogen, right? So in the both the three compounds, remove the hydrogens, because acidic strength means what? How fast hydrogen will release? How fast hydrogen is released? How much the positive charge on the hydrogens? Correct now? So what, suppose the hydrogen is released, what will happen? The compound will be, you can see here negative charge. So there is 6 electron, 6 pi electron here, 2 pi to 4 pi to 6 pi electron. So here is 6 pi electron, and very well in the conjugation system. And here is that one hydrogen will release, the negative charge will come. So there is a conjugation, double bond, single bond, negative charge. There is a conjugation and 4 pi electrons. And third is that here is one hydrogen will remove. So what will happen? There is a negative charge. So what do you think? Which will be more stabilize the negative charge? Obviously there is aromatic, so it will stabilize more than these two compounds. So it is a more acidic than second and then the third. So I hope you understood the strength of the conjugate anions. How you can say that? So how the second anions, how the conjugate anions, how much stable, that decide the acidity. So here is that this compound is more acidic than second and then the third. Correct? Okay, students. Now one more factor I am telling you, the factor is strength of the acid is inversely proportional to the conjugate base of anions. I write here. The fourth is strength of there is a problem in my throat. So strength of the acid is inversely proportional to the strength of the conjugate anions. Strength of the conjugate anions of the base. Correct? So what I am telling you, if it is a stronger acid, their conjugate is the weak acid. Correct? So CH3 minus, I am telling you NH2 negative, and here is the OH negative and F negative. Correct? If it is a strong acid, their conjugate terms, here is talking about F minus. Okay, weak base. Correct? So which is the stronger base? This is the stronger base. So therefore I have written that if the base is stronger, their inversely proportional to the acidic strength. You can see here. Their conjugate terms is a weaker base because acid is stronger. So therefore I have written here the strength of the acid is inversely proportional to the strength of the conjugate base. I hope you understood here. Clear? So if the HF is stronger acid, the conjugate terms will be weaker base. Then strength, if you think about the electronegativity is a sole criteria for acidity, that's not correct. Electronegativity is only one criteria because I am telling you there are so many compounds where electronegativity will not decide the acidic strength. Let's understand one example here. Through the one example, I write here. So the one example I write here that you can understand that how. See, the one example is, see that students. One is we have a CHF3 and second is CHCl3. Correct? One is CHF3, second is CHCl3. If one hydrogen is removed here, so what will form? One fluorine, second fluorine and third fluorine. Negative charge is there. If one hydrogen remove here, we will get that Cl and negative charge is there. What you can observe here, students, there is a vacant d orbital in the chlorine. Correct? So since there is a vacant d orbital in the chlorine, so the negative, that electrons, which is a lone pair of electron present in the carbon, so that carbon will donate electron to the chlorine through the back bonding. So p pi d pi back bonding will observe here. Are you getting or not? Carbon will donate electron to this chlorine because chlorine have vacant d orbitals. So that the carbon will donate electron to the chlorine. So p pi d pi back bonding will be here. So what happened? Cl double bond Cl negative charge. So that the negative charge will be stabilized on the 3 chlorine. So what I am telling you, strength back bonding is inversely proportional to the acidic strength. I repeat, back bonding inversely proportional to the acidic strength. But through the back bonding, if negative charge or positive charge is stabilized, then the acidic strength will be increases. Correct? So here what will happen? That through back bonding, the negative charge is going to be stabilized here. So one and second compound I write here Cl double bond Cl negative charge here is the 1 chlorine, and third I can write here C, Cl negative charge and Cl and Cl. So you can observe here the three degenerating structure you have. It means the negative charge will better stabilized on this compound CHCl3 than the CHF3 because CHF3 does not have the vacant d orbitals. So since CF3 does not have the vacant d orbitals, so how that the negative charge will stabilize here? Correct? So therefore, here is that P pi, D pi back bonding will form. Correct or not? What will happen? Here is the P pi, D pi back bonding will form. Through the back bonding, the negative charge will be stabilized and hence it is more acidic than this CHF3. So electronegativity is not important here, it is the back bonding is there. I write here, back bonding is inversely proportional to acidic strength. Correct? But, write the condition here, but, star. Through back bonding, if charge is stabilized, right? Through back bonding, I write here and there. So I hope you will understand. Through back bonding, if charge is stabilized, if charge is stabilized, then acidic strength increases. Acidic strength increases. Correct? Done. Okay. One more thing, students, to understand here. Intramolecular hydrogen bonding decreases acidic strength. Correct? But in some cases, the intramolecular hydrogen bonding also increases the acidic strength. Let's understand the so many examples here. Okay? So I write one more thing here. Now, intramolecular hydrogen bonding decreases acidic strength. Correct? But in some cases it increases acidic strength. Now understand strength through example how the acidic strength increases. Okay? So let's understand. See. Is here I write strings one example. That example is acetyl acetone, that is tautomeragen. This example is the most enol content, you remember, as compared to acetoester. See here, CH3 C double bond O, CH2 C double bond O CH3. The one reason is if it forms the more enol content because what will happen? CH3 COH double bond CH C double bond O CH3. Correct? So here is the intramolecular hydrogen bonding that the chelate is formed, a ring is formed, and when the between intramolecular hydrogen bond the chelate is formed, that will form the more stable compounds. Correct? So that is the region that due to higher enol content, right? Because the intramolecular hydrogen bonding is there along with the resonance. Okay. So now one more example is, see here, OH C double bond O, OH, and here is the OH. Correct? The hydrogen bond is there. Because of hydrogen bond it forms the ring. So those compound which due to the intramolecular hydrogen bonding they form the chelate or ring, that then the compound will be more stable and the more acidic. Correct? So that is even though urea also formed that intramolecular hydrogen bond, formic acid, acidic acid. This compound will form the strong acid because of intramolecular hydrogen bonding. Correct? Okay. One more example I am telling you, the Cs isomers is the more acidic than the trans isomers because Cs form the intramolecular hydrogen bonding. You understand the example here. See here. One more we can write here. Cs isomer cis isomers is more acidic than trans isomer. Okay, because it form intramolecular hydrogen bonding. Okay, see here, student, C double bond C, and here is the Cl. Okay, Cl, here is the COOH, and you can write here H. Alright. So what happened? There will be intramolecular hydrogen bond will form, even so that the region is there. Okay, that will be the more acidic these compounds. Okay, as compared to the trans compound. But keep in mind one thing, student: if the bulky group is present, then the trans isomer will be more stable, more acidic than the cis. Since there is no bulky group, but what I say, if bulky group present, then the trans compound would be more acidic than the cis. I write the example here. See here. See what I am telling you. If there is a bulky group here, see. If there is a bulky group is there. See, student, the bulky group is what I am telling you. There is a, here is, see student, there is a bulky group is present. I write here, the bulky group is, see, here is one compound, and okay, and the bulky group is there like that, C double bond C. Okay, and here is attached with the hydrogens group I connected here, and the second is a COOH. Okay, here is that COOH and H is there. Okay, so what I am telling you, the bulky group is there. Here is a bulky group. Due to the bulky group, the trans will be more stable than the cis. Okay, because it will not able to form the intramolecular hydrogen bonding. Done. So three things we have to keep in mind: the back bonding usually not enhance the acidic character. Intramolecular hydrogen bonding not enhance the acidic character, but under some conditions both will favor the acidic character. Correct. Now, as far as concerned about the alkane, acidic character of alkane, alkene, alkyne, see here. Student, alkane is that alkyne we have C, and here is the C and single bond C. So what I am telling you, there is a hydrogens, and here is that all the three hydrogens there. So sp2 and sp3. So increase the S character, percentage of S character increases, acidity increases. So here is the percentage S character 50%, and there is a 33.3% and 25%. Correct? So in sp2 and sp3, all we know that. So increase the S character increases the acidity. So of course the alkyne is more acidic than the alkene than the alkane. Correct? Now one thing I write here, student, what will happen when we write the nitromethane and dinitromethane and trinitro? Then check that which is the acidic, how you find the acidic character. Okay? See here. How we go to the acidic character of alkene, alkyne, and C. I write here that students, see that if you have a CH3 NO2, correct? If we have a CH3 CH2 NO2, and here is that NO2, and third I write here CH NO2 and here NO2. Okay, you know, it's very easy, you can say that, because inductive effect is there. So more inductive effect is there, it is more acidic. It is then first it is more acidic than this compounds. But exact regions, what you want to tell? Exact region is, see here, suppose the acidic means what? One hydrogen release. Suppose one hydrogen release there. So what will happen? H negative charge and double bond O, single bond O. Here is that okay, electron will move towards the oxygens. So positive charge will come, double bond will be, resonance will be stabilized, means negative charge will be stabilized, and H double bond and O will form. Correct? So if one NO2 group, the one negative charge will be stabilized through the one NO2 group. If you have a 3 NO2 group, the negative charge will be better stabilized here. Am I right or not? Correct, na? One NO2 group you have negative charge stabilized in this way. If you have a 3 NO2 group, electron withdrawing group, means negative charge will be better stabilized here. Then, so overall what we can say here, the acidic strength like that, you have NO2, here is that NO2, right, and CH3NO2, what we can say, that the CH3NO2 group is the more acidic compounds will form, the more substances, right? Okay, so students, we can write here CH3NO2 will form the more acidic compounds. Correct? Correct or not? And then these compounds, first this compound, then second, and then third. Okay? Now we talk about alcohol and acid, how the acidic character will determine. See, acid we have like CH3, C double bond O, OH is there, and alcohol is there CH3 and CH2OH. Okay. Now CH students, so if one hydrogen is released there, then what happened? It will form, here is that it will form C double bond O negative. And if this hydrogen will remove, then what happened? There is a CH3, CH2O negative is there. Now you think that which will better stabilize the negative charge? Here the two oxygen atom, between the two oxygen atoms, the negative charge will better stabilized. Correct? That is the equivalent resonance. So due to better stabilizations, what I said earlier, the substances which will better stabilize the anions, which is the most acidic substances. So which substances? Here is that negative charge will better stabilized here. Correct? As compared to this here, because there is ethyl group that will not stabilize the negative charge. So hence this compound is the more acidic. Okay? You know, third factor, what we have done? Third factor we have done that first is the strength of HA bond, second electronegativity, and third is conjugate anions, stability of conjugate anions. So you have to check that what the conjugate anions is more stable. After this is conjugate anions, the two negative charge will be stabilized between the two oxygen atoms. That is the equivalent resonance. So it is the more acidic than this compound. Okay, let's see. If we compare this compound through the, here is CH2Cl and C double bond OH. Then is to now if we compare from first to this structure, here what? Negative charge was stabilized between the two oxygens. Here the now, if hydrogen will remove, negative charge will be stabilized through the two oxygen along with this minus I effect of chlorine. So here the three atoms stabilize the negative charge. 2 resonance, 1 minus I effect. Now what do you think about this compound? CH2Cl, CH2, C double bond OH. Then, as we know, inductive effect with the distance, inductive effect decreases, either the plus or I or minus I. So here is the Cl minus I effect will give the less experience on this carbon, on this hydrogen than this. So here is that hydrogens will feel better, more positive than these hydrogens. Correct? Hence, it is more acidic than these compounds and this here. Are you getting or not? So that the logic is here. The how to decide the acidic strength, correct? So I hope you understood it. Students, I am so sorry because my throat is not okay. Despite being, I try to deliver this acidity, but that continuously 4 to 5 lecture will be only on acidic strength, and later when the acidic strength will complete, then I will write all the overall acidity of all the compound, alkene, water, everything. The order will write the acidic strength. But the next lecture will be the acidic strength of the carboxylic acid, steric inhibition of resonance, side effect, steric inhibition of protons. The next lecture is too much importance. So continue. If you understand here, like, share and subscribe the channel, because after all my health is my throat is not okay, despite being I made a video for you. Okay, thank you, have a nice day.